So we are good to go. All right, let's start with any questions. Didn't see a lot of people in office hours, but a number of people have turned in PA1A, so that's promising progress. Any questions up to here, particularly PA1A? All right, well, let's talk more about classes then. So PA1A is our C version of stacks and queues implemented in Java, but done in the style of a C program. PA1B, which we're going to go over today and which will be due a week from Friday, will be the same program but implemented in the style of Java, which means we're going to be working with classes and objects. And so classes we can think of as blueprints or descriptions of something we want to build. Objects are the things that we actually build. So a design for a house might be a class. And it would say there should be a front door, and there should be, a closet, and a bedroom, and a kitchen. I'm making my dream house here. And a garage, and there should be a back door and a backyard, right? And it's sort of a description, and the backyard should be accessible through a back door, and there should be a patio right outside the door, and then there should be, grass surrounding the patio and a fence outside that, right? Now that's not a house. That's a description of a house, right? But it's not a house. Where do you live? Well, I live on this piece of paper that describes everything I just said. It's not the same thing as a house. It's a description of a house. But you could construct a house from that description. And that house might be, called, 200 East Main Street. And you could construct a second house from that description. That might be called, 555 Franklin Avenue. Okay, so the description of the house is like a class. It tells you what are the parts and pieces of this thing. The objects are like the constructed versions from that description. So I can have one description of, a house, and I could construct several versions of that house, several objects, which are the actual houses that are made from that description. And this one might have green grass, this one might have blue grass, this one might have, purple grass. If the description says it should have grass, maybe that grass has an attribute of what color it has and how tall it is. And that could be part, of the particular version of that class. So when we played with linked lists the other day, linked list is a class, and we can construct an object called stack, which is an instance or a construction of that particular class. So the stack is a linked list. We could construct a second linked list and call it queue. Yeah, that is an Engineering 250 schematic. Good eyes. So we can have different objects that are each, constructed from the same class. And once we have that object, right, we can do things with that. We can, set the fields in it, look at the fields, or run code in there, use the methods of it. So for a linked list, we could say add. For a string, we could say, equals, or uppercase, or whatever. And so what we want to do in this course is design classes that capture, the data and the code that we want for whatever it is that our program is supposed to do. And then once we design the classes, you know, we write the code for those classes, and then we can construct objects from those class descriptions, and then do things with those objects. And so we'll start off with some sort of artificial examples. We'll make a rectangle class that will store rectangles. Well, we don't really care that much about rectangles on a day-to-day basis. In this sense, but it'll be an example. But eventually, you know, our classes will be things like, hey, I want to connect my machine to another machine, so I'm going to construct a class, and I'm going to use a class called a socket, right? And I'm going to construct an object which is a socket, and I'll use the properties of that object to say, hey, you should connect to another socket on this machine, you know, across town. And now I can use that socket to send information to another computer, and this is how we network machines, right? Or I could make a class, you know, use a class called a scanner, which says I want to read from standard in, or a class called a print writer, which will be used to write stuff into a file. So we'll dig deeper into classes and objects, but keep in mind this basic relationship, right? Classes are like blueprints or descriptions. Objects are things that are made from those blueprints or descriptions. Alright, so here's what I want to do. I want to go through some coding examples of a particular class, and the class we're gonna start with is just a rectangle, which is, you know, we're just thinking of it as something with a width and a height. And we're going to make, you know, this thing that can hold both pieces of information in a single variable. And so I want to code that in Java. I want to get into the syntax of defining classes and making objects from classes and printing, you know, information about classes and so on. As an intro to kind of the syntax, the mechanics of this. And then I want to make a more interesting class, something for letting us manipulate very large numbers. So a way to represent numbers as an array of digits, basically, and do things like add numbers together and print them out. And we're going to write that in the style of C, and then we're going to convert it into the style of Java. And this is basically what you're going to do for PA1B. You're going to take PA1A, convert it into Java, the style of Java. So we'll go through an example of that, and then we'll look at PA1B in detail, and we'll see how much time we have left after that. So let's start by playing with rectangles. And again, my goal is to be able to represent, you know, a pair of integers, width and height. All right, so let's do some coding. Alright, let's start with a main program. I tend to call my main programs main just because I don't have a lot of imagination. Alright, I'm going to start off by pretending that I have this thing called a rectangle. This class called rectangle. And I'm just going to start using it, and then we'll actually make the class later. So what am I going to do? I'm going to do a rectangle A, B, C. All right, so rect A, comma B, comma C. This is like saying integer I, right? Or this is like saying struct node asterisk sentinel. Okay, This is declaring a variable named a to be a rectangle. But it's not constructing a rectangle yet. Right? So suppose I do this. Let's just say a is a rectangle, and let's try to print it out. Right? I'm going to get a compile error. Well, I get a compile error because I don't have a rectangle class. Let's start a rectangle class. There's my rectangle. All right. So if I try to do this, I get an error from the compiler saying variable a might not have been initialized. Right? I declared a to be a rectangle, but I haven't given a value. So this is like saying integer I and then trying to print out the value of I. Well, C will happily do that, and it will give you, you know, whatever. But Java compiler is a little pickier than that, and it will. Say, sorry?
Where's this Rect coming from? You said it was a class.
It's a class I just created.
Oh, you put it in a different file.
Yeah.
Import that? Sorry,
Yep.
I couldn't see the import.
I was fast. So it's just an empty class right now, just so we don't get this error about no rect.
Have to import it?
No. It's in the same directory, so it'll find it.
Wait, really?
Yeah.
Oh, that's interesting, and also could cause serious problems that I could see.
Could.
Well, not problems, just if you didn't set things up right. That's funny.
Yeah, it makes things a little easier. All right, so we can declare a rectangle, but we also have to give it a value before we can use it. Right? If I just try to print it, I get this error about it not being initialized. So I could give it a value like null, right? And then at least I wouldn't get this compile error. But it's not going to do anything too interesting. Right? It's just going to print out null. So the usual way we're going to give things values is to construct them. And so this is going to be that keyword, this keyword new. So we're going to say a equals new rectangle. We can pass arguments to our constructor if we want. I don't have any arguments, but I've still put parentheses here to tell the compiler, hey, this is basically a function call. It's a method. In particular, it's a constructor. All right, so if I do this, this will satisfy the compiler that, hey, a does have a value. It does point somewhere. And then where does it point? It points to a rectangle, whatever that is. So I can compile this. I can run it. And when I printed out the rectangle, what did I get? I got this weird thing out. It was rectangle, @ and then some hexadecimal number. And, you know, if I make B a rectangle, and I try to print B, well, I'll get, you know, a rectangle, @ and some different hexadecimal number. All right, these are kind of like memory addresses. They're not really, but they're kind of like memory addresses. They're internal references inside Java to this rectangle or that rectangle. So when you try to print out an object, right, so let me put some comments here. A is an object of type rect. This is also called an instance of that class Rect. Right? A is an instance of Rect. B is another instance of Rect. When I try to print out an object, an instance of a rectangle, it shows me the name of the class, an @ sign, and then some internal hex number, which is like a memory address. It's something that the Java virtual machine will use to reference A or B in this case.
And so you don't have to, this class rectangle you made is completely empty, right?
Yep.
I mean, you can assign something to it and it doesn't barf in your face.
No, it's just a pretty useless class. But it's a bona fide class.
Well, I guess what is Callum is pretty fine for me. Maybe it's your audio.
I think it's just sort of in comparison, because the fact that Nick is kind of really quiet compared to you, and
Sorry for talking so loud.
No, that's okay. All right, I'll try to get closer to my mic.
I guess, yeah, I don't. What value would that have? You mentioned a hex. Is that just? I guess I don't know. I'm kind of confused.
So actually, hold on a second, because now I'm.
Classes, they all have like functions or something inside of them. And if you set something to a class, and then okay, actually, never mind. I guess.
So good questions. The answers are coming, but at this point, Rect is just an empty class. It's like a structure that has no fields in it. We could still malloc space for it, but the size of it would probably return 0. But it's a placeholder for our class. We're going to put some things in here first. But I just wanted to get past the syntax error of Rect not being defined. But yeah, it will construct A, and A and B are different things. The thing, though, is that remember, most classes are made from other classes, and a rectangle is going to be a version of what's called an object, and objects have lots of parts and pieces to them. So an object has all of these methods available: a clone method, an equals method, a getClass method, and so on and so forth, a wait method. So I could say, a.clone, and that would be legal, right? I could run that. So even though I haven't put any code into my rectangle class myself, there is code in there. There's all of these methods that are available. Okay, good. I turned up some knob settings. So let's make our rectangle class more interesting. So let's have an integer width. There's some kind of useless comments, but so I've got two integers in here, the width and the height. And now I can do something like, let me get rid of B here. A.width equals 5, A.height equals 3. So now I'm defining a 3 by 5 rectangle. And it didn't really seem to change anything, but I've set these fields inside this class, width and height. So I can add a print message here, and let's say A's height is A.height, and the width is, and print out A.width. So A's height is 3, and width equals 5.
It doesn't complain that you didn't set those variables in the rectangle? Did you?
I set them up here in the main program. So yeah, they're integers in my rectangle class.
Oh, okay, they are. Okay.
Yeah.
Sorry.
That's okay.
Okay, cool, thank you.
Alright, so this is like a structure in C, right? It's got fields, and the fields have types and they have names, and I can refer to those by saying the name of the object, period, and then the name of the field. Hey, birthday midterm, cool. That's actually good, because on your birthday you can celebrate being done with the midterm. Alright, so this is like a structure in C. Let's take it to the next level, and let's put some code in here. So let's make a method for finding the area of a rectangle. So I'm going to call this int area. Alright, what just happened? I wrote another piece of this class, right? There's an integer variable. There's an integer variable. Here's an integer function. It's a function that returns an int. What integer does it return? The height times the width. Okay, which height and which width? This height and this width. Alright, here's the big break from procedural programming like C to object-oriented programming like Java. So, this is the big moment, right? In C, if we want to find the area of a rectangle, we would write a function called area. We would pass it a height and a width, and it would return the product. With an object, we're not going to have to specify the height and the width, because the height and the width are already part of the object. So check this out. Right? I'm going to print out A's area equals, and I'm just going to say A dot area. And I'm not passing 5 and 3, I'm not passing height and width. I don't have to pass those, because the 5 and the 3 are part of A. And when A runs its area method, it's going to say, oh, I need to multiply the height by the width. Well, what's the height and the width? Well, that's, a 5 and a 3 that are part of the object. So this by itself is going to work great. And now if I change the height to be 7, and then I print out A.area again, it's going to print out 35, because when I set the height to be 7, now A is a rectangle whose width is 5, whose height is 7, and A.area prints out 35. Alright, this is the leap to object-oriented programming.
So if you were to pass something into the area, would that be passing through the Rect class? So that way, like, if you have, like, if you want to pass, I'm thinking, like, how, like, what would you pass exactly?
So if I try to do something like this, I'm going to get a compile error.
Yeah, I was thinking, like, if it's 2 and 3, you have to go back to the Rect class, and then take these variables and or those like numbers inside the pass values, and do something with it, and then be able to return something.
Yes, exactly. So this is another key idea, right? This is not a general area method that I can use just to find the area of any old rectangle, right? This is an area method that is part of the rectangle class. It's specifically something which gives me the area of one particular rectangle, whichever rectangle I use to run that method. Now, if I wanted to write something that I could pass 2 integers to and it would give me the area of that rectangle, I would have to do something different. I would have to make a different method that took 2 integer arguments and then I could call that with those two integers and get back their product, right? So that's PA1A. This is PA1B. This is where we're actually saying, hey, here's a particular rectangle, tell me its area. And if I, yeah, go ahead.
Oh, I was just gonna say, I'm used to C#, so you don't need this keyword.
No.
Okay.
We'll talk about the this keyword later,
Okay.
and it'll be useful for accessors and mutators, but it's optional.
Okay.
All right, let's make a second rectangle, B. We'll set the height and the width equal to 2, and we'll print out B's area. And this is not going to be terribly surprising. Right? B's area is 4. But this is pretty cool from a programming perspective, because if I think of B as a rectangle, I'm not thinking of pairs of integers. I'm actually thinking of rectangles now. I want B to be a rectangle. How do I get its area? I'm just going to say B dot area. And it's just like, if I have a linked list and I want to know how many elements are in there, I just say, name of my linked list dot size paren tells me how many nodes I have. So let's extend this. Let's find the perimeter. All right, now we got a second method called perimeter. So let's print out A's perimeter as well as A's area. So after we changed the height to be 7, the area was 35, the perimeter was 24. 5 plus 7 is 12 times 2, 24. Everyone still with me here? Hopefully this is at least a little freaky if you haven't done this before.
Pretty standard stuff to do.
Okay, cool.
So you can't use the dot, methods without declaring a new rect first.
Correct, yeah. So these methods are what we call instance methods. In the sense that, when we say area, we need to have an instance of a rectangle in order for this calculation to make sense. Because if I just tried to run area, what would be the height and width they would use? Right? The height and width in the class description don't have any particular value. And I can't give those height and width values unless I have an instance of this class, in other words, an object. So these are methods that only make sense when we have an actual constructed version of a rectangle. And this is where statics will come in. If we wanted to make a general area method that could be run, we can make it static. But we're not going to do that after PA1A until later in the course. So these are instance methods, right? And they come from having an instance of a rectangle. And really, if I don't have a rectangle, I have no business asking, what the area or perimeter of a rectangle is. Unless, you're doing something very generic, like writing a program that says, hey, tell me how big your rectangle is and I'll tell you the area. Well, for that, this wouldn't be terribly useful because we'd have to actually construct a rectangle. But if we wanted to do something with rectangles, if we wanted to juggle them or, you know, something like that, we would construct rectangles, and now we have access to these different methods.
I have a question.
Yeah.
So we declare the new rect, but we also do rect A. And then we have to do A equals new rect. I guess it's just kind of weird, I guess. I don't know.
So this is a declaration, and this is an initialization or a construction. And it's very much analogous to saying, you know, integer I equals, you know, 1. Well, this is telling the compiler I is going to be an integer, but we can't really do anything useful with I until we give it a value. Right? The first thing we're going to do with I is initialize it. And so we say I equals 1. But a better analogy might be, you know, saying struct node star sentinel. So this is a pointer to a struct node, but it does not point anywhere in particular yet. If I try to do pretty much anything with sent, I'm going to segfault. So what's the next thing we do? We say sent equals malloc, and we'd say size of struct node typically, right? So this is the declaration, this is the initialization, right? These two steps, the declaration and then the call to malloc, those are very, very analogous to this, the declaration of A, and this, the construction of A. And we could do it in one step, right? We could say, you know, rectangle Z equals new rectangle, and then Z dot height, and then print Z's. Right, so you can do it in one step, and more often than not, we end up doing this in one step. But you got to have both pieces. You got to declare it to be an object of type rectangle, and then at some point before you do anything with it, it's got to be constructed or set equal to something that's been constructed. So just like in C, we could skip this step if we said, you know, sent equals temp. As long as this has been constructed, we could set, you know, this thing equal to it. Well, same thing here. I could set rect Z equal A, and now Z is referring to the same rectangle as A. So that's those two steps. All right, let's do some weirder stuff. Alright, so here's a method called normalize. This resets my rectangle to be 1 by 1. What height and what width are being set to 1? This height and this width. Right, the height and width of the rectangle from which I invoke this normalize method. So if I say z.normalize, we should reset this to a 1 by 1 rectangle. Right after I normalize these areas, now 1. Now, if this was, you know, International Rectangle Corporation, and our business was, you know, all things rectangles, this is really nice code, right? I'm not saying z.height equals 1 and z.width equals 1. I just have this idea that, you know, this is the division that normalizes rectangles. And so, you know, how do I do that? Well, I just call the normalize method. All right, let's talk about printing objects. So let me go in into a new piece of code here. So there's A. We'll skip this. Here's Z is a new rectangle with a height and a width. So let's print out A and Z. And we've already seen that this is not terribly satisfying, because it prints out these sort of internal representations, right, that don't mean a whole lot to us. We can tell A is a rectangle, but we don't really know anything about it. So what we're going to do is we're going to write another method inside our rectangle class. This is going to be a method named toString that takes no arguments and returns a string. And I'm just going to return the string haha, because I do that a lot. I gotta make it public string toString. Alright, guess what happens when I run this? It tells me A equals haha, Z equals haha. So you know, I used my print line. I said print out A equals, and I tried to concatenate A to it. And instead of printing out, you know, this funny string rectangle @ hex number, it printed out haha. And when I printed out Z by concatenating that as a string to Z equals, it also printed out haha. And you know, it's not terribly weird. If I make my toString method return the string weird, it'll tell me A equals weird, Z equals weird. So here's what's happening. In Java, if I have an object and I try to treat it like a string, for example, I try to concatenate it to another string, the JVM will automatically look for a method called toString. And if it finds it, it will run that method, and whatever comes back from that method, whatever the return value is, that's the string that it treats as being the string equivalent of the object. So inside the integer class, there is a toString method. And that toString method, if my integer was 17, will return the string 1 followed by 7. And it does that by, you know, figuring out what the digits of the number are. And if it's -17, it'll return a 3-character string, a dash followed by a 1 followed by a 7. Well, here for the rectangle, I've defined a toString method which doesn't do a whole lot that's interesting. It just returns the string weird. But let's do this. Let's say return height plus an x plus width. So now when I run this, it tells me A equals 3 by 5, Z equals 2 by 2. So now I've got a pretty useful way to look at my rectangles. All I had to do was take my object and concatenate it to a string. That caused the JVM to call the toString method. And the toString method created a string containing the height and the width with an x in the middle. And so now when I try to print out A, it tells me 3x5. And so you can create, you know, whatever toString method you want to do anything that you like. And if you don't write a toString method, there's a default one, which prints out, you know, this kind of uninspiring name of the class @ hex number. But you can create your own to print out something, you know, bizarre or weird or, you know, possibly useful.
So I was looking up, is toString a actual existing object or class?
toString is a method. It's a function.
Okay. Yeah, I like to just remember, like, why is it going to string? I think toString is, like, if something is initialized, it would just try to find a method called toString and then do anything inside that block, the code block rather.
Mm-hmm.
Okay.
And I could do something like you know, I could put a for loop inside my toString method, and this is a loop that's going to laugh at me 10 times. And you know, when I tried to append my rectangle A to the string A equals, it called the toString method, which prints out haha followed by a number 10 times. And then it returned, you know, 3x5. And then my print line statement printed out 3x5. So in some sense, there's nothing magic going on here, other than the fact that when I try to concatenate an object to a string, that object's toString method is called. And this is really just a shorthand version of this. Right? So when I concatenate A, it's actually the same thing as calling A.toString, which returns a string and then concatenating that to this string. But it's calling that method, and that method in this case was doing something bizarre, which was, you know, printing out haha and then returning this string. So we'll take that out of there. All right, so that's a little bit bigger of a class.
So the public string is like the default or something?
So when you try to do this concatenation, it's going to look for a public method named toString that takes no arguments and returns a string. And if it finds that, it will call it, and it will take whatever the return value is, and that'll get concatenated to...
Why does it have to be public?
It's just how it works. If I don't say public, then I'll get that compile error about trying to restrict the...
Oh, okay, so you can't concat.
Yeah.
And that's not public.
So attempting to assign weaker access privileges was public, and if I didn't specify, then it was trying to make it protected.
Oh, okay, that's interesting.
Yeah.
So the other one's just automatically private?
The other ones are what's called protected, so they're accessible
Oh,
inside
right,
this
yeah.
file. Yeah.
Okay.
Mostly we can not worry about this or just make things public. For now, toString is the only one where we have to actually say public. But we'll move into that shortly. Question in chat. So switch is a statement in C. It's not actually a library function. It's just part of the C language. And there is an equivalent switch statement in Java. I'm going to recommend, though, unless it's really obvious to you how to use it, don't try to force yourself to use a switch statement in Java, particularly for parsing. For PA1, parsing does not work really well with a switch because we're looking at strings, right? If you were inputting a number 1, 2, 3, 4, 5 and then doing something based on that, that's a really nice setup for a switch statement. You can say case 1, case 2, case 3. But if your input is going to be an S or a Q or an X, right, you'd have to do some work to make a switch work. I would just stick with, if-else statements and process it like that. But yeah, there is an equivalent to switch. All right, so yeah, go ahead. Your microphone is breaking up. I don't know who that was because it didn't even show an unmuted mic. But you went robot. Oh, and I think they just got disconnected. Or maybe they're reconnecting. Alright, so toString is a good method to know. Usually toString does not print anything. All it does is return a string. So we'll talk about that in about an hour when we look at PA1B. But that's an intro to it. Okay, let's talk about constructors. So you notice every time that I make a rectangle, I go ahead and I set the height and the width. And that's kind of a pain to do. So what would be nice is if we could do something like this. Right, if we just say A is a new rectangle whose dimensions are 5 by 3. And Z is a new rectangle whose dimensions are 2 by 2. And now, our code is looking a little cleaner. But if I try to compile this, I'm going to get compile warnings saying that there's no way that I can construct a rectangle with a pair of integers as arguments. The way I wrote my class, what my constructor requires is no arguments. No, your question turned robotic, so go ahead and ask it again.
I was asking if we've done over how to do parsing and in Java or not, and if we have, it's because I have bad memory right now or something.
Sure. Pretty much the only thing we need to do for parsing for PA1 is know if two strings are equal to each other. So you're going to make a new scanner from system.in, which lets you read from standard in. You'll do a while loop which says while, scanner.hasNextLine. And if there's a next line, you can say, scanner.nextLine. That gives you a string. And then you can say, whatever that string is, input or something. You can say input.equals parentheses and put another string as an argument. And so did the person type in X? Well, if input.equals quote X, then put in the stuff you want to do if they type X. Else if input.equals quote S, then do the stuff that you want to do if they typed in S. And then if they didn't type, and to see if they just hit enter, you can say if input.equals parentheses quote quote, just an empty string. And there's no new lines to worry about in Java. So if they just hit enter, then the return from scanner next line will just be, equal to double quote with nothing in between. And if you're doing if-else's, if it's not an X, it's not an S, it's not a Q, it's not an empty line, then you assume it's an integer. And so there you would say integer.parseInt parentheses line or whatever the input variable is, and that'll return the integer. You could do an infinite loop instead of checking for hasNextLine, except if the person hits Control D, your code will blow up. So anytime that you're going to call scanner.nextLine, you want to make sure that you have a next line first. So do a while scanner.hasNextLine, and then inside that while loop, go ahead and call next line to get their input. And the advantage of that is, a lot of times when I run your code, I'll do it by redirecting input from standard in. If I hit the end of the file without hitting an X, and you're looking for has next line, then seeing end of line, end of file, you would just gracefully exit. So that's a good habit to be in. All right, so let's fix up our constructor so that we can construct with a pair of integers. So I'm going to go back into my rectangle class. And I'm going to make a constructor. So
Is a constructor, what really defines this constructor? Is it basically a method that takes arguments?
Sorry, say that again. A method that what?
A method that takes an argument.
A constructor is a method that is called when you say new. So a constructor is a method that's going to be called when I say new rectangle. It might or might not have arguments.
Okay.
So to make a constructor, I'm going to say public. And normally when we write a function or a method, we have to say what kind of thing it returns. Constructors, we don't say that. It's the one exception. So to make a constructor, we just say public, and then we just say the name of the method, which is the same as the name of the class. So I'm going to construct with a pair of arguments h and w, which are going to be integers. And I'm going to use those integers to set the height and the width of the rectangle. I think I'm actually doing these backwards. I'm going to do width first and then height. Doesn't really matter, just being consistent. All right, so now if I say, hey, let's make a new rectangle, parentheses 5, comma 3, the way we can think of it is it's going to call this method. It's going to set w equal to 5, it's going to set h equal to 3. What will this method do? It will set the height equal to, in this case, 3, and it will set the width equal to, in this case, 5. Which height and width? This height and width. Right, the height and width of the object. This will do the same thing as if out here I said a.height equals 3, a.width equals 5. The new keyword is still doing all the stuff it has to do. It's allocating memory, it's setting up things to point to that block of memory, and so on and so forth. But in addition to all the usual things that happen when you construct an object with a new keyword, I'm also doing these things. So now if I run this, I'm back to my 3x5 and 2x2 rectangles. If I happen to put a print statement in my constructor, which syntactically is perfectly legal, every time that I call new rectangle, I get a print message. Almost never is that something you're going to want to do. That would generally be considered pretty poor form, because you don't want your code to be chatty, right? That's the domain of Windows and stuff. You don't want your code to just be printing out messages just to be interactive with the user, right? If I want to construct a rectangle, I'm going to say, new rectangle. I just want a rectangle constructed. I don't want to see messages. So yeah, I know. so generally very, very rare that we would put a print message inside a constructor. So I'll comment that out. But the point is, this is just another function that's being called, and it can do pretty much anything we want it to do, including, constructing other objects, doing loops, doing all kinds of stuff. generally, you know, your constructor should do what needs to be done just to make the object. And if there's other things that should be done, those should go in other methods. You'd like your constructors to be, you know, specific to constructing the object. But technically, you know, you can do anything you want in here. All right, so now we've got a nice little rectangle class we can construct. We can print it out by appending. We can call the area methods, and so on and so forth. All right, questions? All right, let's do a 5-minute break, and then we're going to come back. We're going to create a new class, which is a class I'm going to call BigNumber, and we're going to design this. We're going to write it in a style of C, and then we're going to turn it into the style of Java. And then we'll go through PA1B, which will be basically taking PA1A and changing that from the style of C to the style of Java. So we'll kind of go through the same process you're going to do for PA1B on this new class called BigNumber. So we'll play around with that in a few minutes. So let's come back in 5 minutes.
Nick, I DM'd this, but I'll just ask it now. Am I wrong in remembering that Java has a Boolean data type?
It does. So you can say Boolean lowercase b, just like int lowercase I, and you can set it to true or false. All right, I'll be back in a few minutes.
Booleans again. Excellent.
Yeah, I don't know what that last little bit there was. That was a little scary there, Sam.
Wow.
Can I mute someone?
45 seconds. All right, just about back. All right, so let's dig into our code. So I don't want you to get too bogged down on the details of how this thing that we're about to develop works. My goal here was just to have an example of something written in the style of C that we could then convert into the style of Java, just to kind of see this bridge between sort of procedural programming, where we write a bunch of functions like we did in PA1A or in 222, and object-oriented programming, where we create classes and we put methods inside classes, and we bundle together, you know, data and code that logically belong together. So I just want to sort of make that bridge, and so I'm instead of just doing rectangles, which are kind of artificial, I thought it would be possibly more useful to do something kind of more real. So I want to envision a package of code for manipulating large numbers, okay, big numbers. And the idea is I'm going to take, you know, some big number, and I'm going to represent it as an array of integers, 1 digit per element. So that instead of being limited to, you know, 2 billion or you know, 4 billion billion, depending on how many bits we have, right? I want to be able to have, say, a 100-digit number and do basic operations, meaning addition. I'm not going to do multiplication or anything. But I want to be able to add these together. And ultimately, I want to make a table of powers of 2 that come out in decimal, right? So my idea was, you know, let's take our numbers and envision them as 100 digits. And we'll put leading zeros in the beginning. And we're just going to store these things in an array of integers with indexes from 0 through 99. So a big number is going to be an array of 100 ints, where each int represents the next digit of our number. Index 0 will be the most significant digit. Index 99 will be the least significant digit. So this is how our numbers would be stored. All right, everybody got the idea? And then if I want to add 2 numbers, right, I just go digit by digit. I'll take this element's 99th digit and this number's 99th element, and I'll add those together. And if the result is bigger than 9, I'll subtract 10, and I'll remember I've got a carry, and I'll add that carry to when I add the next digits in position 98. And if that's bigger than 9, I'll subtract 10, I'll set my carry to 1, and I'll add that 1 to the sum of the digits in position 97, and I'll just go all the way through. So this will let me do pencil and paper addition of, you know, 100-digit numbers without bumping into this, you know, 32-bit limit that we have when we just do plain old addition with real ints. So I'm going to call this big main, And this will be for adding big numbers. And let's write some code and some functions for this. This is going to be a really simplified version of this. All right. And we'll talk more about arrays another time, but we'll be doing arrays because I want arrays of integers here. So here's all we need to know about arrays right now. I'm just going to say integer bracket bracket 1 comma sum. And this is how I declare an array of integers in Java. I just say integer bracket bracket and the name of the variable. That makes an array of integers. It's like integer star. Now if I want to actually make an array of 100 integers, I would say, you know, 1 equals new int bracket 100. And we'll see that syntax in a few minutes. But it's the same thing. We have to declare our variable, then we have to construct it. So this is declaring, you know, something like int star 1, int star sum. These are pointers to integers in C. In Java, they're arrays of integers. And arrays are not pointers in Java. They're actually arrays. So I'm going to make a function called makeNumber, which lets me set one of these big numbers to a particular value. And I'm not going to write a general function. I'm just going to, you know, write something that lets me set a number equal to 1 or 0. So I'm going to set 1 equal to, you know, makeNumber. And I'm going to set my variable 1 equal to 1. And I'm going to set my variable sum equal to 0. And I'm just going to keep adding 1 to my sum and print out a running sum. So what am I going to do here? I'm going to say sum equals add sum comma 1. So this is like sum equals sum plus 1, but I'm doing big number arithmetic, right? So my goal here is just to increase my value of sum by 1, and then I'm going to print out that sum using my special print function. Alright, that's my test program. And we need to write a few functions for this. We need to make this new number function, this makeNumber function. We need to do the add function. We need to do the print function. So this is in the style of C. So again, because we're doing this like PA1A, we have to use the static keyword. So static, and this is going to return an array of integers. So we're going to make a new big number. And so here, when we said int bracket bracket sum, all we did was declare that these were arrays. Here we're declaring that this is an array, and we're also saying it's in particular an array of 100 integers. So again, this is like the malloc statement. This is constructing the array of integers. If I don't do this and I try to do something with int bracket 2, I'll get the equivalent of a seg fault. Actually, I'll get a compile error probably saying it's not initialized. Alright, so I'm going to make a result array for my output value. And I'm just going to loop in here. Alright, so that's how I'm going to make my big number. What you missed in the past 3 minutes was we are defining a new class called BigNumber to let us do arithmetic on large integers. And we're developing this code just as an example of something like PA1A, and then we're going to work carefully to convert this into the style of Java, as in PA1B. So the details of this code are not super duper critical. It's just an example. It's a little less artificial than the rectangle example. So make number takes a number n and it basically saves that in the last digit. So this is kind of a cheapo make number. I can only make numbers from 0 to 9. If I were to pass in, a 15, it would put a 15 in this digit, which is kind of bogus. But I just want to make zeros and ones and maybe twos. So so this will work for Wednesday afternoon. So there's our make number method. And next thing we want to do is add two big numbers. So this is also going to return an array. And the idea is we're going to take in two big numbers, A and B. We're going to add them together and return the sum. So we're going to have a new result here, right? Which is an array of 100 integers. And we're going to have to remember the carry each time that we add a pair of digits, and the carry is going to be initialized to 0. And since we're doing pencil paper addition, we begin with the least significant digit, which is in index 99. So we're going to add elements 99 together, and then elements 98, 97, all the way down to element 0. And the only thing we got to remember is if we have a carry from adding two digits together, we have to deal with that. So we're going to go from 99 down to 0. So we're going to add those digits together. And if the result is bigger than 9, we're going to subtract 10. And we're going to set a carry equal to 1. Otherwise, we'll set a carry equal to 0. And when we do this addition, we'll have to add a carry. So we'll do that across all the digits. And then we'll just return the result. And then the last thing will be a print method. So we want to be able to say print sum. So this is going to be static void print, which takes in a number. And so our print method will just go through each of the 100 digits, print them out side by side, and then print a new line at the end. And this should work fine. So I'm going to set 1 equal to 1. I'm going to set my running sum equal to 0. I'll loop 300 times and keep adding 1 to my sum and keep printing it out. compile it, that works fine. If I run it, I get something fairly glorious. Right, I got my big numbers out. These are 100-digit numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down to 300. Okay, arguably a lot of work just to print out the numbers from 1 to 300. Let's make it a little more interesting. Let's print powers of 2. So I'm going to set my sum equal to 1, and inside my loop I'm going to add sum to itself and set that equal to sum. So this is another way of multiplying by 2, just add something to itself. But if I do that, and then I recompile and I run my program, now I've got powers of 2. And they're coming out in like nice decimal form. So there's 2, 4, 8, 16, 32, 64, and so on, up to here. Alright, so this is just, you know, a program that we have for working with big numbers that we're going to turn into a class. But let's make one more embellishment on here. Let's clean up this print method, because we got all these leading zeros in the beginning here. So how are we going to do that? What's the algorithm for printing without having these leading zeros pop up? What should we do? Like just in plain words.
Cut the leading zeros from each number.
Okay, how should we do that?
I don't know. It's been a while.
I mean, just think about suppose you were telling somebody, hey, print out this number, but don't print any of those leading zeros. I don't want to see those, right?
So, here's my idea. Start at index 0, increment until it reaches a not 0. And basically just ignore all the zeros being printed until it reaches a not 0 in between.
Ah. Okay. So ignore all the stuff until we get to a non-zero, and then start printing.
Yeah, but how they code that's a little bit trickier, because it's very easy to just accidentally delete the zeros that are part of the number.
But I like the way you describe this. So ignore zeros until we see a non-zero. Then start printing. Is that fair?
Yep.
So I'm going to make a Boolean variable called ignore zeros. I'm going to set it equal to true. And I'm going to do the following. I'm going to say if num bracket I is not 0, then I'm going to set ignore zeros to false.
Nick, I've got a question.
Yeah.
But won't it throw like a syntax error if you don't capitalize the B in the Boolean declaration?
There are two kinds of Booleans. It's a weird thing in Java. Just like there's a lowercase int, there's also an uppercase integer. There's a lowercase double, there's an uppercase double. There's also a lowercase Boolean and an uppercase Boolean. This is what's called a primitive. And let's just say Boolean ignore zeros, and we don't have to use the new keyword to make this variable. But if we did an uppercase Boolean, we'd have to say Boolean ignore zeros equals new Boolean parentheses true. So these primitive types, int, double, float, char, Boolean, let us do things closer to how we would do them in other languages without having to use the new keyword, without having to think of these things as objects. So lowercase Boolean is legal here. Alright, so I've got a flag called ignore zeros. I set it equal to true to begin with. And as I march through my digits, if I find something that's not 0, I'll say don't ignore zeros anymore. And so in front of this if statement, I'll say if not ignore zeros. Let's print out that digit. And notice that as soon as I find something non-zero, this flag gets turned off. And if this flag is false, I'll start printing regardless of what I find after that. But you gotta capitalize correctly. And you gotta spell correctly. Or spell incorrectly consistently. So there we go. Now we've got, you know, more reasonable looking output. And so there's our powers of 2.
You could almost say that it's a curve made out of numbers.
Mm-hmm. Yeah. Yeah. In fact, you can track logarithms by looking at this curve, because the distance you're out here is the log base 10 of this number. So, yeah, we could do some calculus there. All right, let me do one more. Let me do 2 more things. So if our number was all zeros, we're never going to print anything in this loop, because ignore zeros will always be true, right? Every digit will be 0, so we'll never set this flag to be false. We'll never end up printing anything. So I'm going to put a test at the end of this loop and says if we're still ignoring zeros, let's just print out a 0, because we do want to see 1 0, right? We don't want to just get a blank line. So we'll have that special condition up there. And now let me just add something to my main program. I'll just put a little tag in the front and say 2 raised to the I equals. And now I've got a nice little table of powers of 2. Starting with 2 raised to the first is equal to 2. 2 squared is 4. 2 to the 10th is 1024, and so on. Alright, so that's enough digging into that. Negatively sloped quadratic line.
Don't bother reading that. Don't worry about that.
No, it's interesting. Yeah, it is negatively sloped. And quadratic approximates log for a while. All right, so there's you know, something like PA1A, right? We have a main program, we call functions, we pass arguments to functions, we pass arguments to functions, we pass arguments to functions. And we write our functions in here, and they take arguments and they return values, and so on and so forth. So that's like PA1A, okay? That's what I keep calling the style of C. So now, let's convert this to the style of Java. And what this means is I want to make a new class called BigNumber. And I want to be able to say, hey, let's set let's set 1 equal to a big number, and let's set sum equal to a big number. And I want to use methods inside my BigNumber class to do things like initialize and add and print. And so I'm going to take this and I'm going to put it in a new file called bmain2. And instead of saying these things are arrays of integers, because I want to work with big numbers. I'm going to generate big prime numbers eventually, and I'm going to do Bitcoin mining and get rich, right? So I don't care about arrays of integers. I care about big numbers. The fact that my big number class is using an array of integers And the fact that it's storing the least significant digit down here and the most significant digit here, I'm not interested in that. I just want to use these things to get rich. So I'm not going to say integer bracket bracket 1 and sum. I'm going to say big number 1 comma sum. And I'm going to say these are big numbers. And I'm going to construct this by saying 1 equals new big number 1. I'm going to say sum equals new big number 1. And when I want to add something, I'm just going to say add. I'm going to say sum.add sum. So what's happening here? I'm calling the add method as part of this big number called sum. And I'm going to write an add method which takes a big number as an argument and adds it to, in this case, sum. But you know, I could also do this. This would say, okay, take this big number sum, add 1 to it. But I'm going to do sum, so I'm going to add sum to it. And on my print, I'm just going to use my toString method, and I'm going to print out my sum. Thanks. Don't need bug numbers. All right. So this is going to be my main program. And this looks much more like I'm dealing with objects, right? I'm constructing an object called 1 and constructing an object called sum. I'm using the add method in the sum, and I'm printing out sum by concatenating it to a string and putting that inside a print line message. So now we got to write the big number class. I would hopefully have more documentation than this, but you know, time is short. So this is my class for manipulating large numbers as arrays of digits. So I don't have a main method in my class, right? So I need a constructor. I need to be able to say, you know, big number 1. And that's kind of what I was doing with my make number method. So here's what I'm going to do. I'm going to say public big number and take an integer n. Alright, I'm going to make an array of integers. I'm going to initialize it to be all zeros. I'm going to set that last digit to be n. I'm not going to return it, right? The return from this should be a big number, not an array. So how am I going to actually store my big number? I need an array of 100 integers, right? Where am I going to keep that array of 100 integers? I'm going to keep it inside this class. And so I'm going to do something up here. I'm going to make a variable named the number, which is an array of integers. That's where I'm going to store my big number. And so down here, what I'm going to do is I'm going to say the number equals new int. And inside here, I'm going to set the number bracket I to be 0, and then I'm going to set the number bracket 99 to be equal to n. That's my constructor. Okay, this is a bit of magic. Writing the constructor, the first time that you write a constructor for a class, is one of the most confusing things about this whole object-oriented business. Because when I use this, I don't see arrays of integers anywhere. All I see is a big number. And I say, hey, make a big number and save that in this thing called 1. Well, 1 is not an array of integers. 1 is a big number. It's an object from this class. It's an instance of a big number. So somewhere in that class, I have to have my array of integers. Well, that's what I'm doing right up here. I'm just making an array. I'm calling it the number. I could call it, you know, Fred or Barney or Betty. But it's an array of integers that's part of this class. And so my constructor goes ahead and sets that equal to an array of integers, initializes the values. And now the number is the thing that represents my big number. All right, our add method does not take 2 arguments. It takes 1 argument. It takes the number that I want to add to myself. So if I say sum.add, you know, x, it should add x to sum and store that in sum. So I'm going to make my argument called number to add. I'm going to initialize a carry to 0. I'm going to go through all my digits, and I'm going to say the number bracket I equals the number bracket I plus number to add bracket I plus a carry. And if the number bracket I is bigger than 9, I'll subtract 10 from it, and I'll set my carry. Otherwise, I'll leave my carry at 0. And again, I don't have to return anything. So my add method is void. Right? When I call add, I don't save the return value anywhere. The way I've designed my add function, it adds the argument to something. What does it add it to? In this case, sum, the thing that I use to invoke the add method. So add takes a number to add. It adds it to, you know, the number in this object. Doesn't return anything. All right, and then the toString method. We're not going to print anything from toString. All we're going to do is return a string. And in our main program, when we try to concatenate our big number to this string, the JVM will call this object's toString method, which should return a string representing, you know, this collection of digits. So toString doesn't take any arguments. It returns a string. It's got to be declared public. So I'm not going to be printing in here, right? Because the person calling this may not want to print something. They may just want the string. So, so I'm going to build up a result in a string called result, which I initialize to 0. And then down here, if I'm not ignoring my zeros, what I'm going to do is say result equals result plus the number bracket I. And the number I'm checking here is not num, it's the number. Right? So toString prints a particular number. What's the number it's printing? It's, you know, the number, which I call the number. So for I equals 0 to 100, if the number I is not 0, I'm going to clear my ignore zeros flag. If I'm not ignoring zeros, I'll add that digit to result. And then at the end, if I'm still ignoring zeros, I'll just set result equal to 0. And then down here, I'll return result. So in VI, someone asked, I'm using Control-6 to switch between files. So if I hold down Control and I press the 6 key, it will switch to whatever other file I was editing a moment ago. So if you're in VI, from here you can say :VI, some other file, and then if you want to come back to this one, Control-6 does that. So that's what I'm doing to switch back and forth. I think it's the only VI command that really kind of feels like sort of an oddball. Because why Control-6? I don't know. It's actually Control-, but it's a 6. All right, so here's our B main 2, and we don't need any of this stuff anymore. How's that for a nice little sweet main program, right? And you know, if somebody gave me the BigNumber program, I don't have to know any of these slightly horrifying details, right? All I know is, hey, you know, you can construct a BigNumber, you can give it an argument to tell the initial value, you can add something by using add, and you can concatenate to print out its values. So let's see where we go. Oh, not too bad. Yeah, I messed up. So my argument to my add function is not an array of integers. What is it? It's a BigNumber with a big B. And I messed up again. So the number is not an array of integers. Sorry, it is. Num to add is not an array of integers. It's a BigNumber. So I'm going to do something a little bit odd in here. Num to add dot the number bracket I. All right, what's going on here? Num to add is an object of type BigNumber. It has a field called the number, and so I'm saying inside this object num to add, let's look at the field the number. What is that? That's an array of integers. Let's look at element I. Alright, and we're back to where we were. There's our table of powers of 2.
So the kind of takeaway message is that all the complicated calculations or functions should go into a separate class.
Mm-hmm.
Correct?
Yes, yes.
And, okay.
Yeah, we want to take... Go ahead.
If I was saying that for PA1, basically if we're doing like a stack and queues, the actual functions that manipulate to make a stack and queue goes in a separate class. I guess, is there a specific name of the other class you want to make?
Yeah, it's going to be called myStack and myQueue. We're going to look at that in about 2 minutes.
Oh, so just make 2 classes.
Make 2 classes, one for stacks, one for queues.
Okay.
So yeah, that's a great synopsis of what's going on here. Basically, we want to take all of those details, all that code, all of those methods that we had for doing addition, printing, initialization, and so on, make that part of a separate class. In this case, the class is called BigNumber, so that our main program simply uses that class as another type of variable now, another type of object. In this case, a pair of objects of type BigNumber, right? One in sum, here's how we add, here's how we turn into a string so we can concatenate and print. So do not get bogged down on details in here, because this is just an example. If you're not sure why we're seeing if we're bigger than 9 and subtracting 10, don't worry about that too much. Come back and look at it later, because it's understandable by everybody here. But you know, this is a really fast presentation of it, so it may raise some questions on the first time through, but don't get bogged down by those, right? The important part, the takeaway message, is how we went from from this, where we had a bunch of functions that we had to pass arguments to and get return values from and so on, how we went from that to this, where we had a class that, you know, stored the data inside the class itself and manipulated that data from these different methods. And yeah, so if you're used to doing Java or object-oriented programming, PA1A is particularly tricky because it kind of forces you to go against the good habits that you've built up. And then PA1B will feel much more natural. If you're new to object-oriented programming, then 1A may have felt fairly familiar, and 1B may feel very kind of awkward or unnatural at first. So it's a transition that we're making here. So let's look at PA1B. We've got about 25 minutes left. That's plenty of time to get through this. So let's bring this up. All right, programming assignment 1B, second part of programming assignment 1. But again, you get a full 100 points for this one too. So you're modifying PA1A, and you're creating a pair of classes, myStack and myQ. And all of the stuff that we do with stacks and queues, pushing, popping, printing, all of that stuff is going to be embedded inside these classes. All right. There's sample code you can get to on the server, and you can run it by using this little tag. And you know, it works kind of the same as you know, PA1A. With one important addition, which is for 1B, if you say something like, you know, ha, which means this should be an integer, you should catch that and just say that's an illegal number. So in 1A, you're allowed to throw up if the person types, you know, something that's not a legal command. You're allowed to just let the system throw an exception and exit. But for 1B, the other thing we're going to add is catching errors when they put in something that's not a valid integer. And we may not get to that until Monday, but that's you know, like 2 lines of code you need to add to the finished product. So don't worry about this up front. Don't let it hamstring you. So your main class here will be called PA1B, so it'll be in PA1B.java. You'll create a stack class called myStack, a queue class called myQ, and then your main program will construct a stack and a queue by doing these 2 statements. MyStack stack equals new myStack, and myQ queue equals new myQ. Same Boolean variable to keep track of whether you're in stack mode or not. Same scanner to receive input. Same loop based on has next line that reads a line, parses it, and performs the requested actions. Lots of cut and paste on my part. Okay, but this time to perform the requested actions, you're going to use the methods within the stack and queue objects. So for example, when you see that the person typed in an integer, and you know that you're in stack mode, you're going to call a method stack.push instead of saying stack push stack comma num. Okay, and this is really the heart of object-oriented programming, right? Stack is an object, which means it contains data, which is the linked list, as well as code, like the push method. And if you have the stack object, that gives you access to the linked list. It also gives you access to the push method.
So is stack considered a... So when I say stack, I go to that class, then push is the method inside that class, basically, correct?
Yep, you got it. Exactly right.
Okay, just making sure that when I tell like my class, my class is a name of the class, but then you have Well, my stack, yeah, my stack, and stack is basically kind of like a reference variable. Basically.
Yeah, stack is an object. It's a reference to a my stack.
Okay.
Yep, you got it. So instead of saying stack push, which takes, a stack and a number, we just say, here's the object, this is our stack, this is the method we want to run, this is the argument to the method. So stack.push parentheses num. To pop from a stack, we're just going to say stack.pop, and it's going to return an integer. So now the details of the myStack class look a little different from PA1A. There's a method called myStack, which is the constructor, right? So that's what lets us say, myStack stack equals new myStack. There's a method called isEmpty, which returns a Boolean, does not take any arguments. Alright, so check the description that I wrote here, right? Public Boolean is empty, returns true if the stack is empty. Which stack is it checking? We could have 100 stacks in our main program. Which stack is it checking? It's checking the stack that was used to reference is empty. So if I make a myStack called BubbleT and I say BubbleT.isEmpty, that tells me, is my BubbleT stack empty? If I say, elephant.isEmpty, that will tell me if my stack named elephant is empty, assuming that elephant is an object of type myStack. So we don't pass the name of a stack to this isEmpty function. It knows what stack we're talking about because the way we get to the isEmpty is by using an instance of that class, an object. And once you make that conceptual leap, you're doing object-oriented programming, right? That's the whole jump right there. And more often than not, it happens kind of like, while you're asleep one night, you wake up and it's like, oh yeah, of course. So there's a pop method. It returns an integer, doesn't take arguments. It returns the top of the stack and removes it from the stack. Which stack? The one that you're going to use to say pop. If you say stack.pop, it's a stack called stack. If you say BubbleT.pop, it will pop the top of the BubbleT stack. And this should never be called if the stack is empty. You're allowed to have the program exit abnormally if that happens, but make sure your main program never calls pop if the stack is empty. How do you know that? Well, first call the isEmpty method. If it returns true, don't call pop.
I was gonna say call first isEmpty first and then pop.
Perfect.
Can't get pissed with that because usually when it comes to classes or methods, we keep them very organized. It's a very important thing.
Cool. Yeah, that's exactly the way to avoid getting into trouble here. To push, so void push takes an integer, does not return anything. All it does is silently push the number onto the top of the stack. Again, which stack? The one that you use to call push. Don't have to do error checking in push. We'll assume that you're not going to run out of memory. Alright, last method. This one's a little tricky. The toString method. Takes no arguments, returns a string. And it should return a pair of square brackets with the values of the stack separated by commas in between those square brackets with the top of the stack on the left. Okay, well, how do you do that? A stack is a linked list, right? Inside your stack class, you're going to have a linked list. That linked list has a toString method. If you simply return that linked list .toString paren, you've got your toString method for your myStack class. So you do not have to do any work for this. It's a one-liner, right? Use the toString method for the linked list. So play around with this, but if you get down to more than 3 or 4 lines of code for this method, take a break and think about how you can use the linked list method's toString, the linked list class's toString method, right? Or do it by hand if you want, but make sure you understand how to use the built-in toString for linked list. Okay, important note, toString does not print anything, right? Very, very rare that a toString method will actually do a system.out.print line, right? Why is that? Because not everybody wants to print their stack, right? Maybe you're trying to read the contents of the stack and save it into a file. Maybe you want to take the contents of a stack and run it through a hash function and store it somewhere, right? Not everybody who calls the toString method wants to send the contents of the stack to standard out. And if you put a print line statement inside toString, you're saying, you know, I don't care what you want. I want to print the contents of the stack, so here you go, right? And it's not as useful a toString method in that case. So don't print from inside toString. Print in your main program. Use toString to convert your stack into, you know, the string angle brackets with numbers in between, and you can just concatenate it by saying, you know, print out quote TOS arrow plus, and then, you know, name of your stack. And that will automatically call the toString, get a string version of your stack, concatenate that to the end of your thing that you're printing. All right, Q class is exactly the same thing, myQ. So there's a constructor, an isEmpty, a remove, an insert, and a toString. And these are basically just reimaginings of the methods that you wrote for PA1A. So the constructor does the initialization. These are verbatim, you know, the functions that we had in 1A, and this is a modification of how you printed your stack or queue to, instead of printing, turn it into a string and return that string. All right, submission. So for submitting this and for most of the other assignments, you're going to submit a tar file. And so a tar is an archive. We've done this in other classes, but a tar is an archive. And here's a verbatim command you can use to tar your PA1B. So tar cvf pa1b.tar, pa1b.java, mystack.java, myQ.java. But the general nature of the tar command is tar cvf, which means create, and then the name of the archive you want to create. This has got to be a disposable file, right? This file is going to get deleted if it exists and then recreated. So don't put the name of a precious source code file here, because you'll clobber it. So make sure this is the output file you want to create, and then a list of the files you want to put in the archive. So for this assignment, you have 3 files you're creating. pa1b.java, that's your main method. mystack.java, which has the mystack class, and myq.java, which has the myq class. So I need all 3 of those source files in your submission. This command puts them all together into this one file. It's kind of like a zip file. And now you can just upload pa1b.tar, and bingo, I've got your whole assignment. That's all there is to PA1B, with a little footnote on the word all, because it's a lot. It's everything, right? That's all of object-oriented programming. But when you get through this, right, you will be on the other side of this transition from procedural to object-oriented, and then the fun starts. Then we get to just use this stuff and play with it and use all these amazing classes that are available for us and start doing some really powerful programming. So this assignment you have right now a week and a half. It's due a week from Friday. So you have until Friday to finish up PA1A, and if you take that full time, then you have a week to do this assignment. And it's really just figuring out the mechanics, right? There's no real sort of programmer coding kind of work to be done here. There's a little bit. I mean, you have to concatenate output to make a string and stuff. But we've done, you know, versions of everything you're going to have to do. The real challenge here is how do I create these classes, right? Where do I store my linked list? If I'm you know, doing a mystack stack equals new mystack, where's my linked list, right? How do I return that to the user? Well, you don't return it to the user. You return an object named, in this case, stack, and inside stack is the linked list, right? So just like, you know, over here, inside the class BigNumber was an array called the number. But the main program doesn't need to know about your linked list, just like the main program here didn't need to know about this array of integers.
I see. So basically, when we create two linked lists, one for stack, one for queue, we put one for stack in the stack class and one in the queue.
You got it.
Class.
Yep, that's exactly it.
Okay, that's gonna make things a lot more organized for me.
Cool. And that's a big goal of object-oriented programming. It really helps us organize information, data, and code by bundling code and data that belong together into the same thing. So this is something called encapsulation, and it lets us keep stuff that belongs together. And with larger assignments, when we start writing video games and stuff like that, this is going to be really, really critical. Because if you're making, hundreds of different variables that are interacting with different things and so on and so forth, and you're at the mercy of, naming these things appropriately, it's really daunting to try to do that in a way that stays organized. If you break things into classes and you put all the stuff inside the class, it's a whole lot easier. And so that's one sense in which this will eventually start to feel like the most natural thing in the world for writing code. And going back to writing things in C will feel like, oh, how does anybody do this, All right, other questions?
I'm assuming we'll be using array lists at some point.
So array lists are kind of the same as linked lists. They kind of work the same. They're both versions of something called a collection. And we probably won't play with those too much in particular here. We'll mostly deal with linked lists. But you're welcome to. All right, let me mention something that I've been able to slip past and nobody's asked about it. But let me tell you about it anyway. This is called a signature. We made a rectangle constructor that took no arguments, and then we made a rectangle constructor that took 2 arguments. And over here, I have a system.out.print that takes, a string as an argument. And down here, I have a system.out.print line that takes no arguments. And usually print line takes an argument, it takes a string. But here I'm calling print line with absolutely no arguments anywhere in sight. Now in C, that's illegal. In C, when you define a function named printline, you specify what are the arguments that it takes. And if you say, I'm going to call this with 3 arguments, you better call it with 3 arguments, otherwise the compiler is going to yell at you. In Java, you can have functions that take different numbers of arguments. And so I can have, an integer function, which takes an integer x. I could have an integer function which takes an integer x and an integer y. I can have an integer function which takes a double. I could have an integer function which takes a string. I could have an integer function that takes a string, an integer, and a character. I could have an integer function that takes no arguments. These are 6 different functions, totally independent of each other. They happen to have the same name, but other than that, they have nothing to do with each other. They're completely separate functions from one another. Now, they all have to return an integer, But the list of arguments that they take, the types of arguments, the number of arguments, can be anything I want. And if I make another version of this function with a different list of arguments, it's a new function. So this is something called the signature. Which is the name of the function plus the types of the arguments. Types and, by extension, the number of arguments. So a function fun that takes one int, that would be this function. If I call fun with a string, it would run this function. And you just write these, in your same file as different functions. And the compiler figures out which one of these you mean by the name of the function and the types of arguments you're passing to it.
Are there typical signatures in Java? Because I didn't see you using signatures for making methods.
So the signature is, the name and the types of arguments. So for example, let's go back to our rectangle class. And I've got a constructor here that takes a pair of integers. Maybe I want to construct a square. So I can make a constructor called rectangle that takes a single argument, which is an integer. And I'm just going to set the height and width of the rectangle to that single integer argument. Hope I don't have a main 5. Got a main 3. So now if I want to construct a 2x2 rectangle, I could just do this. Well, let me comment that out. It won't fix your typos for you, though. Right, so I made my 2x2 rectangle, but I used a different constructor. I just said make me a rectangle with a side of 2. So here's an example where I've got two constructors, but they have different signatures. This one takes a single integer argument, this one takes a pair of integers. And this can be useful in all kinds of ways. This doesn't come up in PA1, but it'll come up in other things. But it's just something to be aware of. So unlike C, the name itself of a function is not necessarily unique. The combination of name and types of argument lists, that's what makes it unique. And so that's how Java identifies which function you're trying to call, is by that signature.
Just to make one note here, what defines a constructor is this kind of like, is it basically instructions of what the function does?
Yeah, so the constructor is what gets called when you say new. So when you say, make a new rectangle, it calls the corresponding constructor. And in this case, it initializes the height and the width. What tells the system it's a constructor is two things. One, it's got the same name as the class itself. And two, it does not specify a type of return. It doesn't say void rect or int rect, it's just called rect. Because it's going to return a rect, but we don't put in a type of return value. That's the other thing that tells the compiler this is a constructor. But it's mainly because it's got the same name as the class it's defined in.
basically you're saying like a constructor, a constructor has to have the same function name as a class
Mm-hmm.
to be considered a constructor.
Yep, exactly.
That way, if you were to actually call it or use it, you just say, like, can you go back to your main program?
Yeah.
To see how you call it.
Yep, just like this.
So it's basically how to construct a class per se instead of constructing a method.
Mm-hmm. And if I don't say that, if I just try to call this, right, I'll get all kinds of backtalk from the compiler. Right, because it's not a method, it's a constructor. But when I'm doing this, it looks like it's supposed to be calling a method. So you need the keyword new there for constructors.
So, and I'm assuming new is kind of a way of. What does it mean to actually have a new constructor or something? Is it kind of like I want to take a value and I want to store some calculated value, or what's the what does it mean for new?
What it's exactly doing is it's saying I want to construct a rectangle. Right? I want to call the constructor of this class with this argument, and the rectangle that is constructed, I want to set z equal to that. So it's a little bit like calling malloc in C, but it's a lot more than that. But it's the way that we actually say, hey, create a new instance of this class. Give me a new rectangle. Right? So it makes an object. It does whatever is said to be done in the constructor, and then that object comes back from, you know, this keyword new, and in this case we said z equal to that object. So it goes from that recipe or blueprint for an object to the actual object itself.
Okay.
All right. So that's seriously like, you know, 4 hours of lecture, and we've gone through basically, you know, the entire concept of object-oriented programming. That's a very dense introduction. Things will slow down after this somewhat, at least for a while. But this is the building block. This is the platform on which we're going to put everything else. So the time you spend working with this and getting through these 2 assignments is very much worth your while, right? It will leave you in a situation where we can start having some fun and just start taking classes and putting them together and doing all kinds of interesting things. And by the end of the course, like I say, we'll be doing some networking, we'll be making some games, we'll be doing some graphics, and so on and so forth. So come by office hours if you have questions. I've got hours Thursday and Friday morning this week, Tuesday next week. Bring questions to class, but work on this, finish up PA1A, and then give yourself some time to make this gear change for 1B, and get that done by a week from Friday. All right, we are out of time. I will say have a great afternoon, and I will see everybody next week.